Okay, yeah, I can see that there's submissions coming in using a step file. All right, let's kick this off finally. I should have got my beer with me. All right.
Woo!
Okay. Who am I? Okay, Dean, since you're a Brez veteran in this case, I'm gonna roast yours first.
Oh God.
Yeah. Okay. So this is Dean's capture history, right? You want to remove that. That's gonna slow your laptop right down as well. Do you know how to remove your design capture history? No?
That'll be a no.
Yeah. Resounding no. Okay. Right. So, I mean, overall, pretty straightforward. My first question would be, considering this is an iPhone, what this circle and what this groove is for. I think this is more of a design.
For MagSafe.
NFC charging.
For what?
MagSafe.
NFC charging.
All right, one at a time.
Oh, sorry.
Adine?
It was for MagSafe, for like iPhone 12s.
Okay, right. Gotcha. Speaking of charging, do we have a way to charge it? Maybe one thing that we can add is like a hole down here, and maybe make the stand a little bit larger. Actually, I can probably show you a cool thing that you can do with Step. Is so this is a Step file, right? Oh no. Or this is a Fusion. No, this is a Fusion file that you found it. All right.
I know, because I saved it straight from.
Yeah. All right, let's bring out the sketches. So what was the first thing we learned in CAD? It was sketch constraints, right? So we're going to open this one up. All right, nice one. You got the first one constrained. Now, I'm not going to actually I'm not actually going to critique what the sketches are for, because everyone's got their own, frame of reference and everything. Right. Well, this would be now, guys. Do you think where do you think we need to put a constraint if I'm able to move this one across? So we've got all the radii constrained. So there's two options I can see off the bat here. Where do you think those would be? Anyone can just call it out. In fact, could probably see three. The top one. So we could do something in this corner.
No, the bottom by the angle.
By the angle, this one, yeah.
Yeah.
Yeah. Okay. So yeah, there's one thing we can definitely do here. We can probably set this distance, right? Actually. So we could probably set this distance.
This is probably a really stupid question, but what's the point of constraining stuff?
Look how if I'm clicking this line and dragging it around, right? Obviously, I don't want this to happen. Okay, so when you constrain it, you make sure that you can build out this entire sketch. If you were to draw it on a piece of paper, right? All the angles, all the radii, all of the lengths, such that you'll be able to construct this on a piece of paper. Now, right now, what's happening is we can see over here, there's no defined height between this point and this point, or this corner and this corner, right? So if I'm able to, a good test of this is if I take it with a mouse and start dragging it around, you see it's kind of glitching about all over. So one thing that you would need to do is run constraints, for these different points. Now, you want a height between these guys. All right, so that's no longer moving. See, so those constraints that need to be placed all over. Now, this is one thing that I may have mentioned in the first or second session, is that adding fillets inside of the sketch, if you absolutely need to, do it. The thing is that it tends to remove any endpoints for lines. So what I mean is, when Adine did this, he probably did something like this, and then something like this, and then he probably constrained it to the origin. So let's go from here to there. Yeah, that was the first point. This was the second constraint. And then this was the third constraint, right? And then we can check. Oh, yeah. So this line's got to be coincident. Switch on. Right, so it's got to be coincident or collinear with that point. Yeah, see, now it's turned white. Now I cannot move it. So I'm clicking it, I'm moving it, it's not going anywhere. So we know that this line is going to be collinear along this y-axis to this point over here. It's 84.818 away, 52, and then whatever this this gibberish number is, okay? So this is constraint. Now, there's one little glitch inside of, I wouldn't even say it's a glitch, it's kind of a, it's just the way Fusion does things, right? If you go to fillet and you select this corner, right, select 11 millimeters, if you hadn't constrained it previously, this wouldn't constrain either, right? So one good way would be, okay, so we've got 3, 2, 3, and 1. What I would recommend is when doing a design like this, let's just say I'm going to delete that there. I'm just going to do these two corners. There's a neat little tool over here. It's called extend. So if you go under modify, extend, and what it's going to do is it's going to kind of extend the same line. So you don't need to create a new line from this point. Okay, because points do get taken into account, and if you start to extrude, it's going to create a whole mess of things. So try to always have a single uninterrupted line going back and forth. Now I'm going to turn the bodies off here. All right, so we've got these two things. Now there's another tool. It's called the trim tool. So you can remove the excess bits that you've extended. Okay, so now you've got these two. You know this line is constrained. Okay, you know that we need to put an angle between these two. So a good way to go about it, I'm going to remove most of these angles here. So these are connected, and then extend these, and we're going to do the same for this. Cool. So now we've got a closed profile. Now we need to make sure that these lines are all specified and they conform to the general profile that we want to achieve. So this is where we put the constraints. So we know that you've got this line, it's got to be a certain height, right? Then we need to have a certain angle between these two lines. So you specify that there, and you just keep going around. Now, the reason why this is constrained is probably because there was a previous block, right, that Adine made out here, which is it's taking it as reference. But if you didn't, your next step would have to be to create the create the constraints here around this angle, around this angle. Now, once you've created these constraints, you can go around putting fillets already within the sketch. So make sure that your overall, profile, that's all set out before you start putting the fillets. Okay, we need to make that 1 millimeter. And I think that was 3 millimeters. No, that's 2, and then that's 2 there as well. Okay, so that's all constrained, and now I can no longer, move this part around. It's all nicely constrained, and you're not going to have any shifting issues. So once we put this body back, what we can do is create a new block. So let's say, let's take the distance between there. So it's 50 mil and 60, 50 by 60. And we'll actually use that point as a reference as well. So you can create references in between different sketches. So for example, if I've got everything constrained in this sketch, it's quite reliable. I can use that as a reference in another one that's right next to it. Yeah, so we'll join that one up. Now, I can either cut through this one or just select the intersect Boolean here, and that's going to leave this shape. All right, so this is one approach. Another approach would be to actually leave the sharp angles over here and then create the fillets using this this tool instead. And that would actually, I find that in my workflow that tends to be faster and more applicable. But then again, to each their own. It depends on what you're doing. But I found that that also shows fairly good results. Okay, now, next thing you need to do, you wanted to create the circle. Now, again, this is one thing that you always need to pay attention to is constraining. So we've created a certain circle, but this circle isn't fixed in space, right? If you're working with different different people on the same project, chances are, or your hand might twitch or something, you might move this off. Maybe not that much, but an entire millimeter. But a millimeter is going to put it out of alignment of, say, another component that has to fit inside of it. So again, it's always good to find where the origin of this certain plane is. We can say this is here, and then just marry that up to that particular component. Okay, now I know it's constrained. There's another way to do this. In fact, I'm going to remove these guys. If you want it to be positioned in the middle of this cube, we know that this was 60 millimeters. Well, we're going to put that to 30, and then do is actually inspect, check that this is perfectly centered. Okay, so that's about, say, 90. Now, Dean, if the circle needs to be on a particular height, you probably had calipers to measure up against your phone. Let me know. But say if you want it to be in the middle of this segment that's between the fillet there and the start of the fillet there, this would be one way you can do it. Okay, there we are. So that's perfectly centered. Finish that sketch. That's constrained, so that's not going anywhere. And then we can cut in like this. Yeah. Wonderful. Now, the same situation is going to happen over here. You probably have a sketch. No? Okay, you don't have a sketch for an opening. So to create this opening, there's two ways. You can either create a square and then another line and use that to sweep it through, or you can just create another sketch on this surface, line it up. Now this line segment probably has a midpoint somewhere, and this is what CAD is very good for, in terms of computing it. So it'll find that midpoint. So you can draw that 90-degree line. That can be your construction line. You know that this is 5 millimeters deep. So you can do do something like this, and then set the distance of this line to the surface. Sorry. Okay, we set it to 5 mil there. Okay. So now we want to make this opening a little bit larger, rather than copying. I mean, you can draw this out again, but there's an easier way to do it, and that's just to mirror it across. So select the objects that you want to mirror over here, select the line, and that's all done. Yeah. Now there was one little mistake that I've made. That's obviously I didn't use the sketch plane. I used the sketch plane that Dean created when I had a slightly different angle. So these things, they might catch you out. You might not notice that, or if you probably did, then great. What I needed to do is actually to create the circle on a new plane. So that's what we're going to do now. A quick way to get rid of the feature. You can just delete that. Create a new sketch plane. I believe that was about 50 mil, and we're going to do the same thing. Okay. That was the old measurements. Divided by 2. Okay, that's all constrained. Brilliant. All right, and now we can just cut into there, and we've got the same result. All right. If we're 3D printing, obviously, based off last session, there's 2 ways we could print it. I mean, you can happily print it standing up the way it is, or you can turn it on its side, so you can actually on its side like this. So most of you, what would you choose, which orientation you would choose and why? Can you tell me? You just shout it out.
Cut out upwards on its back.
Yeah, cut out upwards on its back. And any reason for why you would want to do it that way?
Because you haven't got any overhang otherwise, apart from maybe the little lip on the bottom to hold the phone.
Mm-hmm. Yeah, absolutely. So, one way you could do this. Yeah, so one way you could do this is put it on its side like this. All right, you would, if you actually throw this into Cura, the first layer that's going to go down, it's going to go down quite quickly. You've got a lot more, stiffness, because if anything, this thing's going to be bending around this axis, right? So you want this to be an entire singular shape. You're going to get much sharper corners over here because the extruder is going to have effectively no layer height resolution limit in this case in the XY plane on the print board. So it'll make these corners quite sharp as well. So those will turn out quite nicely. And like Robert said, you don't have any overhangs over here. Okay, so it's going to print. It's effectively skipping this, capstone region, this keystone region.
Just to say, I meant the main back, the big surface.
Oh.
That way, the entire cut up is facing upwards.
Oh, so you want to do it like this as well?
Yeah.
Yeah. That could be one way. In fact, so the printer will handle, a slight overhang like this. So that could be another way of doing it. So again, this is quite a robust shape. You can do it in most ways. It's just some ways it'll go a little bit faster, others a little slower. But it's really up to you in terms of where you want the stresses to go. All right.
What do you give it out of 10?
Would I give this a 10?
What do you give it out of 10?
What do I give it out of 10?
Yeah.
Okay. Well.
The balance looks off. That's my main concern. Like, you put the phone on, it looks like it's going to fall over backwards.
I mean, we have to. Let's see.
I'd argue that's okay.
But you have to keep in mind it's going to be printed out of PLA, and modern phones are heavy, It's a top high. It's a high center of
If
gravity.
it's got enough base down, it should be okay.
Yeah,
but
if
look
anything, it needs to be a little bit taller and a little bit further out. I mean, actually, right, engineering 101. How do you establish if this is more likely to tip and prone? It's a little clue. This has to do with center of gravity. You want the center of gravities to align. So center of gravity of the phone is probably going to be somewhere, here, depending on how long your iPhone is. iPhone's probably, I don't know, 13, 14, 15 centimeters long, depending on how large. Okay, so it's about 6, 7 centimeters up. Yeah, this is 86. So chances are the center of gravity is here. So center of mass for this product, right, would have to be somewhere, as far back as possible. So it's not as easy to tip over. Now, one thing we can do that is check the center of mass on this object. Okay, center of mass is way down here, right? Do you think this would be at risk of tipping over? Because effectively, your rotation point is going to be about the center of mass for this.
Well, yeah, because the majority of the weight of the phone is past the halfway point
Okay.
in the first place, and then it's past the center of mass as well.
All right.
We've got a lot of designs to rate.
Yeah, we've got a lot of designs. I'm going to try to go quickly through the other ones. Will we give this? I'm thinking a 7, 6.5, 7.
I was going to go
I could
6
agree with
for
that.
lack of creativity.
All right.
I'm happy with that.
Yeah. All right. There's one other thing I probably missed is that this gap needs to be directly in the center. So I'm going to use this as a little learning opportunity on how you can use one sketch to reference another. I'm going to remove this one real quick, and you can actually remove. Yeah. What's up?
Okay, wait for creativity, right?
Yeah.
Yeah.
Be prepared. See mine.
Okay, so if I create a sketch on this plane, on the indent, there's going to be, it'll automatically either find the center, or you can go into create, project, all right, and what it's going to do is it's going to use the features to be included inside of the sketch. So if I hit OK, right, you see that purple line? That is a projected sketch that was either been used in other sketches or from the physical features of this body. So if I switch off the body, this is constrained in space. It's not going to go anywhere, but you can use it to reference it, right? This becomes very, very useful as you go along. So as I mentioned in the first session, do have a look at these features. They will allow you to do some really insane shit in CAD. I'll even show you later. You can effectively create the entire underground tube system in terms of projections using that method. I'll show you in a minute what I mean. So once you've selected that, just create a line out just along here, and we'll turn that into a construction line. Now you can go even crazier with this. Actually, no, we'll keep it at that. So once you've done that and you create a new sketch, what you're going to do is you can use project again and include this line. Now, because this line intersects this plane, it's going to leave a point, okay? A point which you can reference to create a third construction line, which is perfectly aligned with the center of that circle. Now, if you can go ahead and find other ways to do this. This is just the first thing that came to the top of my head to describe these functions, but it just shows you how useful it is. And once you get more and more complex shapes, how you can kind of navigate using different planes and different axes to get to where you need to be in order to make a second sketch. We'll go with 7. Mirror that across. Where's it gone? Oh, punch that through. Okay, so now that's centered. All right. Cool. Okay, so 6.5, 7. Bonus points for creativity and for multi-component ones. So I think I mentioned this in the last one, but other than that, looks good. That's pretty sound. That'll print well. All right. Moving on to the next one. I'll try to go faster on this. Should we go into the Garbo phone holder? All right, Sahan, you ready?
Yeah.
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 It's exactly what it says on the tin. So.
Right, going in humble. I see. All right.
But there is a good reason.
Okay, let's go with. For some reason, it's not opening up.
Drag and drop.
Yeah. Oh, it's not cooperating. Create fusion design. All right, here we go. So I think it's just going to move that across.
Can I just move it in like via the thing, the client?
Are you able to? Is it showing up now?
Let me just wait. Actually,
Oh no, is this really going to take that long? That's painful.
you're gonna wait a while to see my amazing, beautiful work.
All right, so you've gotten it to work. Oh sweet, okay, that one's opened up as well apparently.
Oh no.
Okay.
Create fusion things. Oh right, okay. This is what I've literally just generated a fusion design from this. Okay, now this is going to be quite cool because you'll see how you're able to work with step files and how much you can interact with them. So I don't see your sketches, but I think right now, off a Dean's example, I've been able to show you, hopefully get across the importance of constraining your sketches and making sure they don't shift around, and what happens when they're unconstrained. You see the lines, they just go all over the place. That's going to create problems down the road for your design. So everyone's got that. We're not going to cover that anymore. Now we're just going to look at the actual design. Right, so definitely I can see extensive use of splines here. I do have one question. Which way is up? Is it okay? Is it meant to be like this, and then the phone sits in there? Yeah.
Yes.
Yeah. Okay. Wonderful. All right. 2 holes. That's for cabling.
Yeah, for cabling, or like if you want, if you're not like putting your phone there, it's just like a cute little elephant, or it should be, like.
I see what you're going for. All right. Okay. So obviously no charging port.
No, because like when I was like thinking of like a phone holder, I always thought of it like going at the side, because it's like, if you want to watch YouTube videos or something, then kind of just have it at the side, and the charger's just there anyway. So kind of like I was like, oh,
fair.
Yeah.
Fair. Okay. Well, definitely trying to make an iPhone stand look like an elephant. Those are 2 very, very different shapes. So I'll give a 9 for creativity there, trying to match the 2. But we'll see how we can stack it up against dimensioning.
The width and depth of the trunk where the phone sits, is that been measured and calculated to hold a phone, or is it just eyeballed?
No, an offset should have been used.
It's just eyeballed. I was just relearning like all of this stuff like earlier today, so
Quick learning.
Awesome. All right. Okay, so I see 140 millimeters. So I'm guessing the phone sits sideways in here. Yeah.
Yeah.
Okay. All right. Very nice. We're not multi-component, so I'm gonna have to slash you on that one.
fine.
Yeah. Right now, in terms of printing, okay, which way would you post this?
The way that's like kind of with the trunk on the side, like that, just a
On
bit
the side, yeah. Okay, yeah. So these circles, printer would normally do that. You might get some rough edges up here on the slight patch, but generally it'll be able to do that.
Right.
That's not a problem. The only The only qualm I would have maybe is this corner for printing. All right, so this edge, because it's technically going down to an infinitely small point, this is where I'll show you how you can interact with step files. You can create a fillet, you can select the size, and we can go, say, 1 millimeter, and it will do that.
Yeah.
Okay. Now, when you're working with step files, you'll see it might create a few artifacts. See that bit right there? That little corner. So if you actually see something weird sticking out,
Ignore it. Just turn the other way.
don't listen to Ben. If it looks weird, it probably is. Okay. So let's see what we can do about it. I mean, Control Z, undo. It exists for a reason. So you can try actually deleting it and seeing what happens. Oh, right. Okay. So that's been resurfaced. That's no longer a problem. Okay. Might have been a glitch, but it's gotten rid of that corner. If we try to go and delete that edge again, no, it doesn't let you delete it. Okay. So yeah, actually it gave me a warning, can't delete individual faces. So apparently this was a second face that was created on top. So I'm guessing because of the way that was done, were you trying to use, were you using the surface form?
Yeah.
And then stitch it? Yeah.
Yeah.
Okay, cool. All right. So it seems you've created two surfaces. You've stitched one onto the rest of the body, and then one was kind of left overlaid. That's why we got the edge. So it was literally lying on top of here with a corner out. So we just removed that duplicate edge. Maybe it's worth trying to see if we can, if there's a second one. Ah, no. All right.
Ed,
Okay.
sorry, 1 second. I know that we skipped past this, obviously, but Pavel is trying to get his design in. What's the method if he can't do it?
Yeah, so tell him, is he watching now? Pavel, are you watching?
Yeah.
Yeah. All right. So go to File, go to Export, and then the type of file, click on the drop down and select Step. Okay, just this one. All right, you select Step, then you select your directory, wherever you want it to download to. I'll put it in my Downloads folder, and select Export. Once you've done that, go to your Fusion client. You would have seen if you've been added to Roast My CAD. If it shows up in the web client, you can hit Upload and drop it there. If it doesn't work that way, in fact, just drop it into the chat. I'll upload it myself. Because I think you said you had the upload whited out. So just drop it into the chat and I'll upload it for you. Just make sure you export it as a step file. Yep. Okay, cool. All right, so you create the surfaces. Are these stitched together? Yeah, these are stitched together. All right, cool. Guys, what should we give it? So I think since we gave Adin's a 6.5 and a 7, we'll go with 7.5 for creativity here and technical. Definitely nice job on working with trying to use surfaces and figuring that out. So it's not multi-component, but it's multi-method. So should we give that an 8? Yeah.
Yeah.
Yeah, good use of curves as well. Stops warping when printing because you've got no right angles.
Yeah, there we go.
I think an offset would have made that look a little bit neater, but otherwise, yeah.
Yeah, we'll go with 8 on this one.
Thank
All
you.
right, no worries. We'll say that. Right. Let's go. What?
Someone is typing furiously on the laptop.
Now, I might need to adjust the scaling. I might need to put this instead of out of 10, out of 15 if there's exceptional ones coming up. So we're going to change the scaling as we go.
Yeah. Out of 12.
Out of 12. It's moving out of 12. Okay, so 10 is fully met expectations, and anything above that is exceeded expectations. I think you have done a 110% job.
Top scale.
Apparently in the military, when they assess you, like a 1, so it's on a scale of 1 out of 5, and 1 just means you're doing your job.
That makes sense. Why would you want to be below?
It makes sense, but imagine just being an average student, it's like being a straight F student.
Avatar fan.
Right.
This is impressive. Yeah, a little bit of Avatar.
Okay,
Yeah, I like this
right.
one.
Yoshi.
I'm here.
This is good.
Thank you.
I like the lack of excess material around the back. You've
Yeah.
sort of trimmed it down to
Yeah.
cut down on print time.
Yeah, very trim. I mean, my only design concern would be maybe making this foot out.
A bit longer.
Yeah, a little bit longer, but good use of fillets. The print extruder is going to go around that quite easily. My only concern for printing really here would be this is technically an infinitely small and infinitely thin. What's it called? Yeah, infinitely small plane. So right now we're gonna see how to fix that. So technically, I mean, this is right up there. You've done everything right with the lettering. The lettering's good. Yeah. So
Can I just add, how are you planning to print this one?
Nah, I'm gonna be honest. I don't know how everyone was saying that. Everyone just kept on saying on the side, so I'm just gonna guess on the side.
I mean, it's the only flat surface that would avoid using support.
But then you're going to have problems
The
with that
letters.
text or the
yeah.
shapes. So
I suppose straight up might work.
it's beautiful,
Okay,
depending on
not
the-
sure if it's printable.
but what's the workaround around that? Okay, so sure, you might not be able to print it, or you might need to put support here. And generally, I try to avoid using supports because they tend to extend your print time. They mess up. Sometimes they fall over. And
Waste
then they leave.
material.
Yeah, waste material. They're a pain to get off. They're an absolute pain to get off, and they leave a rough edge on the bottom here. So this is going to be all mangled at the bottom. That's just how it runs. So what would be the work around this?
Have the front as a modular piece, so you can then screw in different parts for bigger phones or smaller phones as well.
No, you can do that. Okay, but someone else apart from Rob. Can you
Yeah,
tell
Rob.
me? This was probably from the first or second session, and actually the in this particular case the solution it's so easy, and you can 3D print it as well. Just not in the sense, not in the obvious sense.
Also,
No? Okay.
Mm.
Well, you can turn this into a multi-component. So technically, let's go with, we can split body. Use that as the splitting face. Do that, and now you've got. Yeah. So now you've got the. No, it's right there. Right there, yeah. So now you've got the letters separately. So what you can do is you can print the letters separately, and then you can print the. So V is actually the hotkey for visibility, and you can print this separately, and you can actually glue these guys on. So what you could do is you can print the lettering on their back, so the extruder will be running top to bottom like this. You'll get very, very neat letters, right? Very neat letters. You won't need to have any supports, like say in the S or the O, to create a floating, piece. Which actually, once I get to Luke's design, you'll see what I mean. You won't get any of these floaty bits, and then you can just happily, glue it on. Like I said, nothing needs to be printed in a monolith, in kind of this one single monolith piece, if you could figure out a way to assemble it properly, right? So that's always worth keeping in mind. Now, now that we've got this bit over here, okay, we need to fix this extrusion. All right, so I believe you've gotten the line extruded and everything, but you need to make sure that that this is an actual 3D volume that's being protruded out, because right now this is just infinitely thin. So a workaround to this one might be okay, while we're at it, how to create groups. So right click on body, you select create group, you can highlight all of these letters and then just drag and drop into there. If you just, all right. So what we're going to do, try to do is we're going to extend all of these surfaces, all of these edges. We're going to extend it into this body, and then we're going to cut and cut and extend. All right. So, actually, no. That will be the second method. The first method, we'll try to patch it over. So we'll create the patch tool. We create this volume.
Perfect.
No, that's not actually what we... No. Okay, so it's not creating... All right, we'll move on to method number 2, since it'll be a bit faster.
I'm really appreciating the fan support for Avatar out here.
Thank you.
All right, we'll just line this up so we can just select the... Okay, so if you want to just select edges, there's the selection tool. You go to selection priority and select edge priority, and that's only going to select edges. All right, so that's...
While Ed's doing this, how did you actually design this? Did you just draw it out by hand, or did you import something?
I imported it. I don't know what. I used to insert thing and it insert as SVG or something like that. And then I had to.
Did you go to insert canvas?
No, it wasn't Canvas. It was SVG.
Okay, right. Okay, very cool. Very cool.
Good.
Very
Use.
hard since it all came as little separate pieces when I did that.
Oh, well, I'll give you extra points for actually going out and figuring out the functions. So because that's pretty much the only way you can get around, learning CAD. So.
I thought this was drawn manually. I was amazed. Not that I'm any less amazed, but.
Whoa, Rob, that's hard.
Yeah, I was trying to draw.
All right, let's Right, this is being a slight pain. What we can do is we're going to join all of that up. Now, if we use that.
What's going on, Ed?
Well, what I'm trying to do is use these guys to split the face on this and then extrude it out so that we can close it up and actually make it printable. Because right now the issue is that this is a 2D plane, right?
Yep.
Yeah. So what we're trying to do is we select this and then we select the surface as a splitting tool. So it should create almost like a split line. It says no intersections between target and splitting tool. So I find that quite odd, unless you've got gaps somewhere. But this is going to be an interesting one because it'll show you how to troubleshoot. But since it's one surface, technically it's it's a closed profile, so we shouldn't be getting issues like this. We're gonna run through a really good troubleshoot because once you get dodgy models, you'll know how to debug them, right? Okay, what's the next thing? What's the next thing that we can try? Under inspect, there's a validate. So what it's going to do is it's going to check whether you've got any gaps, right? So refit bad surfaces, small edge removal. Yeah, so we can do that. Okay, so that's sound. That's fine. Okay, what if we'll try that again now. Incidental to create legal non-factor. There's another split face. Okay, so what we can do is we can actually split that face. Okay, yeah, that's going to work. Right.
Yeah, Dean, you're the one to blame for this.
I'm gonna have a whale of a time editing this out.
Two objects. So we're going to move that.
Just while Ed's doing this, who's made the phone stand and coloured it?
Aye,
Who's I? Because I'm just seeing lots of names.
that would be me.
Danielle.
Yeah.
I'm liking the use of appearance on that.
£10. Guess who inspired me?
What inspired you?
Have a good look at it. Try and guess.
The problem is it's so small.
Is it a windscreen mount, like for sat nav?
The color scheme.
I don't know. I just see brick coloured.
All right. Let's make sure that Rob never goes into interior design.
Oh dear. Right, so this is proving to be a challenge. You have challenged me with.
Are you challenging me?
If
Yeah,
it makes you feel better,
yeah.
this was really hard for me to make. So
So this is redemption, right? This is okay. So
I
what
feel
I've
less
tried.
bad now.
So what we've tried here is to you know what, we're going to go into surface here, and we're going to see if we can actually split the surface using this shape. Actually, do that. We're going to create a sketch. We're going to use my favorite project tool. All right, so we can go project to surface. Actually, no, we're just going to use the project tool. And what that's going to do is that's going to create a whole new surface around it. So let's just get rid of that body there. Yeah, you're going to find in CAD there's a lot of clicking. If if you screw up, there's going to be a lot of clicking for you to get around this. But we'll get there. That's fine. In fact, what we're going to do is we're going to select the priority, selection filters, select all, click face priority. So this will go a little bit faster.
Can't you just do a click drag highlight?
Yeah, unfortunately, it's not letting me do that.
Ah.
I mean, what? Okay. Is it? No, it's not.
You have to get the whole thing out.
No, I've tried to get the whole thing, yeah.
All right.
Select all. All right, there we go. Yeah. No, for some reason, yeah, no, it's not doing that.
All right, okay.
Okay, so we've finished that sketch, and then we can go back into the sketch and continue on with projecting the rest of the stuff in.
Hi, can you just select it from the menu? You know, the browser menu, and like highlight everything. You see like the bodies on your left.
No, these are for the yeah, no, unfortunately you can't do that. So because you need to select the individual elements, because a body is all of the elements put together. So we're talking about every single edge. Oh, I wish there was a shortcut for it. We can try doing this again. No, let's run it. Create project. All right. I know this will definitely work once it's a closed profile, and you'll be able to just extrude that thing right out.
Can I ask, while Ed's going around having a click on every single face, the design of this thing, who's already made their mind up on what project they might be joining later?
I'm pretty sure I might go into the medical.
Medical, yeah. Or does anyone have any questions about the projects that they want to ask now while I'm here and distracting people? Sorry, I can't really hear someone. I think.
No, I can't hear either.
You're a jester for now, then.
Yeah, I'll just entertain.
The best part is once I get fed up, I can just save it and then start reprojecting again, so I don't suddenly like click out and then I lose all the progress.
Quick save.
Yeah, honestly. Right. But let's. I mean, we can extrude that thing out. I mean, how much was it supposed to be? Let's go 1.5 mil. That's fine.
Doesn't it go in, not out?
I mean, yeah, okay. It depends. It depends which way. You can go both ways. We'll go out this time. But that's not the point. I think once you can get this from projection to extrusion, you can do whatever you want with it. So the most important thing is to translate it from just being a surface into something where the body can, well, in the body format, in the volumetric format. Okay. Did I just switch on a section analysis on that? Oops. That's all done. I'm not going to do any more. You get the gist. Otherwise, we're going to be here forever.
Do we get this?
Do people get the gist? Just to clarify before.
Oh, 2 people get the gist. All right.
You get it. Let's move on.
You want me to keep clicking? Is that what the?
This is what your torture is. Yeah.
Yeah. Day 4. Yeah. A few moments later. All right. All right. So, I mean, this is what we got. Definitely. What should we give this? Since we'll give this a few points above the last two. Should we put a 10 on this?
I think creative, good use of different skills, definitely importing the design great. However, the whole 2D face and possibly very complicated to print, I would deduct some marks from.
Yeah, so we'll go with a 9.
I think a 9's a safe bet.
Yeah, because I can see they've experimented with multi-surface. Now, just for those who didn't get the gist, what happened was that. Let's go with this surface. Yeah. So what you see over here, this is an infinitely small 2D plane. You can see that, yeah. So even if I hit that, it only gives me a length. It doesn't even give me a thickness. Okay. And this was done using the surface form. Okay, not the solid form. So what's going to happen is that it won't print. Okay, it's paper thin. Okay, it's infinitely thin. Now, what I was doing is trying to translate this paper thin to something that's that can be extruded out, very much like this this little embossed, logo over here, or like the letters, right? You see they're sticking out. So one way to do that was to create a sketch. Okay, you go into Edit Sketch, and what you do is you go to Create, Project, and you select the geometry that's going to be projected into the sketch, right? So you can hit a few of these lines, hit OK. If we turn that off, you see that it creates these lines. Now what I've done is I've created a closed profile somewhere over here, like this round square and the swirly thing, and then you can use the extrude function to extrude it out, and it's actually part of the body. All right. Okay, so I'll save that. Now you know exactly how to translate it from 2D to a 3D surface in case you end up in a situation like that. Right, moving on. Let's go to. I keep forgetting it's not. Need to create a fusion design. I'll create. We're gonna go to Luke's over here. Yeah, literally the skeleton. All right, Luke, you're up next. Yeah, so use of appearances and material. We're actually going to use the wireframe to be able to look through that. Now, I do have some concerns regarding this. Okay. Yeah, the Brez bit.
You've got floating blocks.
So we
in the B.
I forgot to color it, or
is it okay? This is connected. All right. Cool. Okay. I see what you mean, because I thought these were just like floating in the air. I thought.
Well, how are they connected? Colored.
Yeah,
that's right.
Well, how would you get the phone in there?
Ah, right. No, you almost got me. You almost got me. Right. So, Luke has not figured out levitation.
Damn it.
Okay, and there's a few artifacts over here. So definitely needs a lot of debugging. I mean, I'm not sure. Ooh. Yeah, definitely messy. Yeah, this is unforgivable. I'm sorry, man. I'm gonna have to give you a 5 for this.
No problem.
Right. Right.
The phone can't really sit in there either, can it? Because the letters get in the way of where the phone would be, right?
Yeah, I'm thinking that. Yeah, this groove. I'm guessing this is for the cable, but
charger.
Yeah, but this would need to be. If you hit Q as a hotkey, you can press pull that out. But I think it's bugged out to the point where it's not even. Yeah, it's not.
Structurally speaking, the sharp angles, especially at the base where the back of the phone would be resting, that's not great either because it could break more easily.
Yeah,
mouses.
Unless you print on the sides and you actually use the materials at parent strength. You're printing it upwards. That's not going to run. Okay, so how can we improve this?
Start again.
Yeah, do we get another take at this?
I'm sorry.
You get another take. I mean, stuff like this. You should have been observed. But like I said, we're not going to bollock anyone for this stuff. This is all quite obvious. So we're going to go and debug the technical bits, right? So if you want to create lettering, I mean, to start with, it would have probably been worth making the lettering go through only the front step of this bit. So,
oh wait, yeah, I know what you meant. I did it. Yeah.
So between here and here, well, here and here, yeah.
Yeah.
So, and to leave some material, obviously, if you're going to create a charging, an opening for the charger port, it will be closer to this backrest, right here, or maybe you leave a bit of material near this edge and a bit of material on this edge and make it centered, just large enough for that cable to fit in. And this needs to be larger because your cable, unless you have like a 90-degree cable or some special one, your actual cord is going to be bent all the way down here, right? So you won't be able to stand this up. So what I'm going to do, I'm going to move these guys into here, and I'm going to do a quick little sketch based off your design. So let's go. Can someone give me a bit? How tall is an iPhone? Some of you may have done measurements.
I can measure my phone.
Yeah, hold on. I'm gonna grab my calipers here.
I can give you the height of an S7 if you want.
I've got an A3. It's about roughly the same size. So it's about 70 mil, and it's about 140, 70 by 140. So it's 2 to 1s. Okay. So we go 140 mil up, and then depending on, let's pick an angle. Let's go with 60. That just seems right. Yeah, okay. Now, obviously, there's going to be a bit of overlap, so we're going to go to 150 mil. Actually, you know what? Now, for 3D printing, 5 millimeters, depending on which orientation you're printing in. Let me just refresh that real quick. Oh, cool. Oh, Pavel, you've managed to get it through. Nice. Let me know how you did it after.
I uploaded it in the chat. It's somewhere there before the meme.
Okay. Right, so we'll go with 5 mil, but technically, like for PLA, if you go with 3 mil and you actually print it in this plane, so on its side rather than standing up, 3 millimeter wall thickness is more than enough. It'll be very, very strong. Right, so we'll put this line out here. Now, obviously, this needs to be constrained to this line, so we'll go around about there. We'll hit that trim button and we'll get rid of the excess. Make sure that's parallel. There, how tall do we want to make the lip? Let's go with 10, 12 mil. Actually, no, we can. Yeah, because we want the lettering in there, we'll go with 30 mil.
Keep in mind how much of the screen you might be blocking all the buttons.
Yeah, fair point. Right. Do that with 30 mil, and then how thick is the phone? So if we've got a 5 mil gap, that's yeah. Let's go with 22 millimeters here. Oh, that's weird. Okay, and then you can use that parallel constraint. You can just use it for days in this case. You don't even need to put any numbers around except for some distances. And then we'll make this also 5 millimeters thick. Obviously, we're going to extend this a little bit further downwards. We'll get rid of that bit, and then we can trim off the excess over here. So yeah, we've got a nice, neat profile. And lastly, we want to create a step that goes out to the back. So what we'll do, in fact, we can probably reconvert this line just to avoid us from having to draw another one. So you hit that one, you can hit X to convert it between a construction line or not. Okay, so that's the hotkey for it. So you can hit X to do that. Draw that line there. We say we want it to be collinear with that base, so you know it's 5 mil up again. And then finally, you want this thing to be, let's go with 45 degrees. And you want the end of this base to be, well, not further than there. So actually, let's go collinear. You want that point point of that? No? Okay. 52.445. All right, so that's all nicely constrained. We can trim that off. Right, so you see, I removed that one, and now it's no longer constrained in terms of distance where it's got to be. Okay, so we can do one thing. We knew that that the distance between this one and this one, we want it to be 12 millimeters. Oh, we'll stick that there, and then it's reconstrained again. So we're all good on that. So now, no matter which one I click and try to move it, this is a fully constrained sketch. Now, remember how I mentioned you can do the fillets before or after? I'm going to show you what the advantage of doing it is after. When you're creating a sketch with a bunch of sharp and parallel edges, obviously you can see how quickly it went and how easy it is, right? So what we're going to do here, trim that a bit off. Yeah, so what we're going to do here is we're going to extend this out by 17 millimeters one way. Okay, so we've got our little, monolith thing there. And then if you hit F, that's the hotkey for the fillets. And go here and create something that's about 2 millimeters. That's going to remove any of the stress concentrations in this point. And then the cool bit is rather than doing that fillet in the sketch, you can actually make it as large as you want. You can do something really, really funky with this. Let's go with a 25 mil one. Yeah, so I think that looks pretty good. Right. And then we can try going with you hit the shell function, and the shell is going to give you a 5 millimeter distance from each point, from each edge. It was hit extrude on. Now the shell function, like I said, it's only going to create almost like a tub, right? So it won't get rid of the end. So what you do is you just select that face, hit extrude, and just cut it out to the end. Yeah.
Can you do that bit again? Just
yeah, sure.
Please.
So you've done this profile. If you want to create a hole over here, you can either do it in the sketch or you can do it after. If you know that you want, if you're designing something arbitrary like this, you hit shell, you select the face that you want, and then you see what it does. So if say I had like a 1 millimeter, technically this would actually still print. That would be really cool. But we'll go with something a bit simpler. We hit 5 millimeters, so you want it to be 5 millimeters from each of these outer edges. And you hit OK. Now, the thing is that you see that there's a face at the end of the shell. Yeah. So the shell function is basically all it's going to do is make like a tub. Okay. So it's got 3 or 4 edges and then the bottom. Right. You can hit
useful for making boxes and stuff like that.
Yes. There you go. So you can hit extrude and then just cut it out towards the end, and now you've got a through hole.
Okay. Cool.
Hit F. Select these 3 edges. Hit that 2 mil, and then you've got the same kind of a gap going on. All right. Cool. So we'll do this. We'll keep the sharp edges there. That's fine. That's more of a design feature, especially if you're printing it on the side. You'll have more adhesion surface. So we'll go with that. Now, because we want to do a hole like a hole for charging, what we're going to do is create a sketch directly on this surface, and I'll explain why.
Just real quickly, because I think some people have to go because we're already now almost an hour and a bit in. Can we just quickly critique some of the other designs after this, just in case some people need to go?
Yeah, absolutely. Okay, so what we can do is we can create this box, and inside there, well, pretty much, we're almost done.
Is there a way to do like a center line or something?
Yeah. So
on that plane?
Yeah, there is. So what we can do over here, if you hit the line function and you drag it down, this gives you a midpoint. See with the triangle? Yeah. So it'll just snap to it. And what you can do is hit X and create that as a construction line. Then you can go somewhere down to slot, center to point slot. What it's going to do is it's going to snap to the midpoint again. And you say, okay, iPhone charger is about 5-6 mil. So let's go with a 4 mil, and then we can extend that out straight to the edge. And then what we do is we just constrain the radius. And to that point as well. All right, so that's all constrained. That's all good. I'm going to show you a little trick with the extrude function as well. You select that profile, and I think you can do it. Okay, it's not that one. It'll be the sweep function. So you create the sweep function, and then the path. And the path, you can select it like this. Yeah. That's a sweep function. If it was windy, it would go all over the place as well. So you can do that. Now you've got, the charging hole itself. We can go to press pull. Now press pull is almost similar to extrude, but what it's going to do is it's going to move this thing out and extend the edges. And we're going to bring this out another, say, 10 mil, so that we can create a hole for the charger cable to come through, all right? But we'll get around to that later. It's basically more of the same operations, but this will be one way that you go about it. We can press pull this face out, another 5 mil, and we can emboss the lettering in that as well using the text, okay? So I'll just save that there. You can use that for reference, and we'll get back to that shortly. Now, so yeah. These are some points that you can improve on.
Is it better to cut into it or to cut out of it? Do you understand what I mean by that?
Yeah. So if you're going to cut out to it, it's the same as I mentioned for this one. If you're going to cut out, you could do that, but it's better to actually print the letters separately and then glue them on. That's kind of for the final product. That works best. If you want to just print it directly, then cutting in works better.
Okay.
If you want to go in one block like that, yeah. All right, iPhone holder. So I'm guessing this is meant to be desk mounted.
Iron Man.
There we go.
That's
very
cool.
nice.
Oh, that makes sense now that I see it. Yeah.
I love the ketchup mustard.
McDonald's.
I like the ketchup mustard colored scheme. All right, so definitely, I'll give him a plus for
the imagination's there.
Yeah. So, is this going to be printed or multi-component? So I could see that that it would require multi-component, but I don't see how connections would be made. So this is quite tricky. I do like how you're using the edges here to maybe to lighten the design up a little bit. What I would recommend is placing stuff like fillets around here so that you can avoid any stress concentration, so you don't get cracks around these areas. So you can do that. Maybe 3 or mil, yeah. You could do something a little bit like this as well. I reckon printing a tube, wouldn't really recommend it. I would probably recommend actually having an insert and then using like a carbon tube or aluminium or plastic.
Or metal rods.
Yeah, exactly. They can cut down. So, printing stuff like boxes, tubes, pipes, that kind of stuff doesn't really make sense. There's much better manufacturing processes or existing material that you can use for that.
Yeah, I wanted to talk about a copper tube, but I didn't know how to explain it without making.
Okay. Okay, gotcha. Actually, we can go to appearance so we can actually find a carbon tube here for you.
What are the cutouts in the base for? I'm trying to figure out how it mounts.
Yeah, does it go inside one of those?
You're gonna have balance issues otherwise.
Yeah, what does that mount to?
was hoping to make a screw or something so I can like. But I didn't get around to doing it. Like, so you can screw into the base.
Okay, to screw into place. So is this meant to go into like one of those you know, in the desks you have that hole with a slot where you route your cables through?
Yeah.
Is that what you think? Okay, right. I see.
Right.
Well, definitely give it plus for using, you know, existing, you know, furniture features. I think that's you know, considering design to be integrated or fit together with other stuff that that you find. That's quite cool.
Definitely.
That angled joint round the back looks a little frail, though.
Yeah.
Yeah, that one.
Yeah, there's stuff. Yeah, there's definitely stuff we can improve. I mean, around this, you know, to improve
Put
the
a screw through it.
yeah, to improve the frailty, you can make it not as frail. So that way you can, I suppose you can put a bit of a fillet. Now you can see, you know, it's less likely to look like it's going to snap off. And the same thing.
Yeah, ideally you put something just going straight down, because that kind of angle, that kind of joint there, where it meets the mount itself, I think would be a bit.
And keep in mind, you're going to have force on it when you put the phone on or where you're tapping at the screen.
Yeah, exactly.
How much repeated stress can it take?
Seems nice, but it seems a bit frail, this one.
Well, I mean, what we would do is maybe increase.
Well, thicken it, increase the diameter.
Yeah, so we can use the press pull function even on cylinders here. So you can increase that by a certain amount. Now, these are two different, these are two different functions. So you've actually, I'm guessing you've put, you've used a sketch to kind of make that cut over there. So what we're going to do is, let's create a construction plane.
It's an interesting use of the cut to sort of align it properly. You know, you can't, like, if you're assembling it, you won't like sort of have it askew.
Yeah.
It's always going to sit in that well.
Yeah.
Yeah. So what I'm going to try and do is to project the surface. Now we'll go with the project function. Okay, interesting. It's not projecting it fully. But what I want to try and do is get this curve out, you know, just as a line here, so I can slice it after. This is okay, and then the curves, that thing along the vector. Yeah. Okay, so there we go. That's how you can do it. So what I'm going to do is I'm going to combine this one and this one together. Now the coloring, we can fix that after. That's not really an issue. All right.
Extrude up to the point.
Yeah. So we can extrude that straight up. See where it would cut? We just change that to join. Yeah, and then
if you send that fillet all the way to the end of the circle, it'll be a smoother.
Yeah, there we go. We can do something like that. And then, I mean, I'm doing this arbitrarily. I'm not picking any.
Yeah.
Yeah, so something like that. And then, let's see, sketch. Now, obviously,
Right.
we want this to go out a bit further.
I'm gonna have to see you later. Let me know who wins the design and who we're printing thing for. Hopefully, you get through them all.
Yeah, yeah, no, we're almost there.
Cheers, guys. Thanks.
So,
Bye.
That's it. Okay, and then we can kind of. Come on. split body. Yeah, splitting tools. So we'll do that. Don't worry about this bit splitting to this one because you can quite easily just hit the two together since they're butted up right next to each other at infinitely small lengths. This is where it will join, and then you can see that this is an entirely separate body. Actually, you've got these guys that are separate here as well. And go to appearance, and then yeah, cool. All right. Oh yeah, and lastly, you can kind of get these guys there as well. Okay, so yeah, overall, quite decent. I mean, Rob, what should we go with this one? Should we go with a 6, 7?
Yeah,
6, 7.
I mean the sort of the inspiration for the designs there, but the frailty of it sort of brings it down a bit.
Yeah, yeah. I say yeah, we'll go with a 6 on this one. In that case.
Yeah, that's fine by me.
Yeah. All right, we can add a couple of fillets here as well, and then also on this side again to just clean up the design slightly. I think this is just more of an aesthetics question than anything else. You know, you don't need these sharp edges, so you can kind of you can run with something like that, you know, and then that definitely looks neater. Just so you don't have sharp edges on here, you can use chamfers. So bits like this, and then you can put a millimeter on that. Yeah, so it just clips the edges, doesn't scratch up your phone. But really, yeah, I would take a look at either gluing or putting a screw kind of from the bottom through to here if you want to combine these two,
Yeah.
right?
Maybe thicken the plate a bit as well.
Mm-hmm. Definitely. Definitely. Oh right, this is joined up. I'll probably combine these as well. So I'd recommend putting fillets around most of these 90-degree parts, even if it's just a small one. That already significantly increases the strength of the joint. Yeah. That's more of an engineering consideration than anything else. But that, yeah, I mean that's a pretty good start. So you've used different components. I see you've put things at different angles. So you've worked with trying to combine certain different designs. So definitely good work. Yeah, we'll give you a 6 for that one.
Yep.
Now,
I think we had one
more
left somewhere.
Yeah,
I think
in the chat. I uploaded it in chat.
Oh yeah. Okay.
In the chat.
All of the memes. Okay, gotcha.
Oh no, Jesus.
Oh, that's not what we were looking for. So you can do 2D designs. Right. Oh, very nice.
Oh, that's a very big base plate though.
I think that's a table.
Yeah, that's a table. I just like.
All right.
Right, okay.
Let's put that into a render.
Yeah,
Let's put that into a render.
It's very clean, but it also looks very thin and frail, especially with the cutouts on the back.
Hey, you know what? This type of presentation maybe wants to put it into a render. So I mean that's going to a straight 10, and then we'll see what how far we can push it. Very cool. Very cool. Okay. Now we're gonna move back to the design.
You can
bit.
hide the phone in the stand.
Yeah. Yeah. It's, Okay, that should. All right, there we go. Very cool. So now I'm guessing. Okay, first couple things. Was this part of the design, or this is more like a glitch? type thing.
It's part of the design. It's supposed to be like 2 circles in between, and then I merged them, kind of. So I couldn't
Okay. All right.
line. I don't know.
All right. Okay, I do see a couple of challenges here in terms of printing, like trying to get the honeycomb. I think because to do something this thin.
I think it's made out of 2 parts, though. It's 2 components.
Yeah. So I mean, I definitely like that, and I definitely like that. You're probably thinking about gluing or using.
I was even thinking seeing it on the metal plate and then bending it. You know.
Right. Okay.
Maybe it'd be easier.
Yeah, if it was laser cut metal, it would make more sense. But structurally, to be 3D printed, it'd be a little weak, I think.
Yeah, I mean, it can. I mean, Rob, 1 millimeter is like it's pushing it, but 1 millimeter, I think it can do it. I mean, we've done rocket nose cones 1 millimeter thickness, so you know this.
Yes, but that's a cone, whereas this is just a flat piece with an entire phone weight on it. So
that's fine. He mentioned that he wants to actually explore the sheet metal options, and you know there is a sheet metal thing. So quite honestly, I haven't actually gone in and had a look. So we can try that, because apparently you can convert a body to sheet metal. I'll take a look at it after. But okay, with the consideration that he wants to do it out of sheet metal, this is totally doable.
Oh yeah,
it's totally doable.
Yeah, no, that's out of metal. Yeah. That's fine. Yeah.
Yeah. So I'm guessing. Well, I mean, would you tack weld it? Would you use some kind of industrial adhesive on this point? What's the idea behind it?
I don't really know. Maybe I can.
Really know.
Could do M2x2 countersunks, I suppose, or something small like that.
Yeah, definitely. I mean, overall, I mean, it looks really good. You don't have any sharp edges, you know, none of that. I really like this design. There's only maybe one qualm would be, you know, is that you've created, again, do you want this thing to tip back slightly, or do you want...
I haven't noticed that it's not on the same level.
Okay, so all right, this is what I'm going to get you then.
You know?
That's it. This is what I'm going to roast you for, like these things. Okay.
Oh
yeah.
Lack of parallelism there.
I don't know if it's just me, right? You know, when you're designing for precision, you want these things to be aligned, right? Okay, so let's take a look at what's going on here. I know this is the last submission for the day. Parts of. Oh, okay. Right. So how did that happen? Because I'm thinking about how to fix it now. Okay. Right. Let's see how we can fix this. So obviously you've created. There was a sketch done on this side. Okay. You've extruded it, and then you started punching holes, you know, from this plane. Now, what I think happened is that you created a construction plane that was at a slightly greater angle than this line, and yeah.
I don't know how it happened, but it was like 3 separate parts, and then I merged them together, and apparently maybe there is like a glitch when you had to like smooth these corners, and it like turned out to be like this. I haven't noticed it before. I don't know.
Okay, I can't seem to remove it. It's okay, right, there we go. So you need to be in the right mode. Okay, and then we can go
and just fill it out from the
Oh no, it's doing the same thing.
Huh. The vertical bits, are they different bodies if you combine it with the horizontal part?
0.9 millimeters. That is very thin.
That's tiny.
Okay, so was there a consideration for units when you created this, or it was just eyeballing it?
I'll say eyeballing.
Okay.
I was like trying to make it. I don't know.
Oh no. I mean, it's in the right length scale. So you got about 60 millimeters, and I think my Samsung A3 is like what 70 millimeters. So okay, no, it's in the right scale. That's fine. I was just like, so there's one thing that I'd recommend. There's this inspect tool, or the hotkey. You can use I for that. You can check these things, right? So if you would have checked this side, you would have noticed, okay, 0.9, that's probably pushing it in terms of thickness. So you might have some issues there, but there's ways that we can fix that. So what I'm gonna do, and I know there's 0.9 from that side. What we're gonna try to do to fix this, this is 6 millimeters. What we're going to do is get rid of that. Okay. I'm going to create a sketch on this plane. Right, so now we're working in this plane over here. And what we're going to do is just create a line. I mean, how far do we want to make that go 6 millimeters as well? Yeah, let's make it go 6 mil. So make sure that's all constrained. We can reference the physical, the body geometry there, so we can see that's constrained between these two entities. Okay, so we'll finish that sketch. And then what we'll do is we'll just extrude that out. We'll join it. Okay, so now I know this looks like a big ugly block here, but we can fix that as well. So we'll split this body. It's unhandled. Okay, strange. Actually, you know what? We can just extrude that through. That's a much easier way of doing that. And then shave that off as well. Yeah, see where I'm going with this? Now you see, technically this line, yeah, that shouldn't be there. Okay, so what we can try to do is we just delete that. Sometimes there's a glitch in terms of how it recomputes the surface. So, but when you realize that technically this is one entire surface here, that line, it shouldn't be there, and you could quite easily just select one and then delete it, see what it does. So that's another way to debug the surface. Now we can just insert the fillets back to where they were. Let's see. The radius on that is 1.95. Sorry, that's 1 millimeter. Okay, yeah, that's close enough as far as this representation is concerned. Actually, no. Actually, that wouldn't be correct, because what you've got is that I just completely eyeballed that one. You don't want to be doing that. What we're going to do, we're going to create an arc. Let's go with actually, no, let's go with a 2-tangent circle. Know that the distance between so what we're trying to do is put this exactly at 1 millimeter, right? Yeah, okay, so we can use the offset tool. So the offset tool is this one right here. All it's going to do is move an arc That's 1 millimeter out from that existing body. So we're using this curve as a reference now for you. Right, and then if we go back into the sketch, we can close that profile. And then cut it out, and then we should be able to delete these, because these are like infinitely thin now in theory. So yeah, we've got that. That's perfectly aligned. There shouldn't be a step in here anywhere. No. Okay. Cool. And finally, we'll just put the fillets back in this position, and we can see that there's I believe there was an arc running back here. So what we will do is so we've got that arc back, because I believe that's what you initially specified, and then we can go back to the fillet tool and restore these corners. We'll go with 2 millimeters. Yeah, so now you can see that these are completely flush. You see? Okay, so that's the first component. And the second component, I mean, that looks completely fine. So I don't really have any issues. So we can finally we've gotten rid of that weird corner over there, and actually, I'm guessing you wanted these to be lower than the hexagon. So we can hit the press pull, use Q as a hotkey there. And this will just go down to 2 mil.
Or you could just extrude it down to a given point and then set the point as the base of the, the lowest point of the hexagon.
Yeah, but he's got a gap here, so I was thinking give him a gap there. If you want to, I mean, what you could do is when you hit extrude, you can go start. This is your profile plane, and then extend. So you can go to object, and what you can do is you can actually select that as a distance.
The vertex.
Yeah, and then your offset, you can go. Sorry, let me just actually measure the distance. So I'm going to show you how to exactly, how to recompute everything. If that's 1 millimeter, then if we do the same thing, distance to object. Okay, certain distance. Whoa. Can we just go down -1? Yeah. Okay, there we are. And then we just put those 2 fillets back where they were, so they're no longer covering the hexagon. That should be fine. All right. There's another thing that you could do that would be quite cool. You can create a couple of gaps here using the shell function. So the shell function, what it's going to do, it's almost like creating a box, right? You see what it's doing? It's creating a hole kind of in this position. Actually, it's done something really strange here. Did you notice that? So it's actually cut into the surface there. Now, my question is, I'm really picky about precision right now. Yeah, that's 1 millimeter, and we'll check. Yeah, that's also 1 millimeter. Okay. All right, never mind. Yeah, so that looks pretty good. My last suggestion would be to fix this, but I think you've gotten a good grasp of how to do the rest of the stuff. If you wanted to fix it, you would, I suppose, just create a sketch onto here, and then create a new. What you can do, in fact, is create a project this geometry into the sketch. So now it's like a usable line. You can actually remove the previous component there. You've got a usable line, and you can extend this out. Now, you know this wants to be directly, collinear with this one. So you use the collinear constraint, hit that, and then hit that one, right? So now you know this line, this is your new baseline. And then what you can do is you can redraw a curve. Let's go with the circle, and then a 2 tangent. Select that one, you select that one, and then you pretty much go with whichever diameter you want. Offset. You go -1 millimeter. Okay, now. And then you convert that to a construction line. So that's no longer a carrying line. It's not gonna affect. It's not going to be a profile for anything when you're extruding. And what you can do from here, in fact, is at some point, run a line up here and actually redo this bottom lip. Okay, I'm not going to do it, but this is one way. If you've got a skewed drawing, rather than trying to recenter it, because that would take a lot of time. If you just need to get this done quickly, this is one way about it. Okay, so definitely, I love the design. I'd probably hack off some points for accuracy. So looking at accuracy, so should we go with like an 8.5, 9?
Yeah, that seems good.
Consideration for different material. So sheet metal, trying to CNC. We don't actually see a lot of people wanting to CNC something. Normally it's just 3D print. So definitely, if you want to spend time and actually take a look at how to create a solid body into sheet metal, that would be quite beneficial, because we're always happy to encourage multi-material, multi-component manufacturing. So not just 3D printing, but 3D printing, laser cutting, CNC, using carbon tubes or any kind of extruded, other materials that you can get in abundance and for very cheap, and kind of piecing it all up together, because that really defines, efficient design and manufacturing. Okay. All right. I think, we've gone for quite a while today, but that's it. So
got to pick a winner.
Yeah, for a winner, you know what? I
like that engraved one.
Yeah, this one right here. So
yeah, that's the one.
Congratulations, you are the winner for today.
Yay!
Yeah. Mainly for trying to actually import SVGs. In fact, because you can import a canvas as well into every single different plane. So like an image, if you ever want to trace something, or in fact, that's exactly what I've done for this seat, right? So I said I wanted to CAD something up. I had canvas here that had the ejection seat image as a reference. Now I've just kind of modeled it out and then exploded, but that's what you can do. You can insert images and then create sketches around that. I think, there we go. You can see the sketches that were done. So definitely nice work on doing that. You've tried to do something with surfaces. You've combined different surfaces. You got some lettering in there, and the actual design itself was quite sound. So I can see this being quite functional. You can check something for accuracy and tolerancing. So yeah, 10.6. That's enough to fit a phone in. So no, very good, very good. Congratulations.
Thank you.
All right. So what I'm gonna do is I'm gonna actually get these splines done. In fact, now that you've seen how to do it, you can do that yourself. You can submit the redesign, and we'll get printed out and sent over to you.
Oh, great. Can you since you already did some of it, can you save it and then re-upload it so I can?
Yeah, you know what? Since I've only got a couple of contours, it'll take me 5 minutes. I'll just finish it up and print it off and get it over to you.
Oh, thank you.
Yeah, fantastic. Ben and I will sort out how to post this or whatever if you're on campus.
I'm not on campus.
Not on campus? All right, we'll figure out a way to post it to you then.
I'm like 2 hours away from uni.
Gotcha. All right, well, congratulations, everyone else. Thank you very much for like participating. I hope this has helped out in terms of like troubleshooting and I hope you guys have managed to learn something today, or take something away from it. Definitely keep practicing. I mean, practicing's gonna get you ahead quite a lot, but I think you guys are on the right track, so you're good.
Thank you so much.
All right, no worries. Take care, guys. Have a good evening, and see you around.